This is question number 4 from 6-2W lesson that you got wrong. So I'm just going to go over that one, kind of describe it, and then how to set it up. So starting off, we are looking at a similarity problem. So if these two triangles, I already highlighted them in green and I guess that's aqua or teal, whatever you want to call it, so that you can see the different sizes of them. So let's see, FOD is the green one, and then HOG is the teal one. And so what you want to do here is it says that they're similar. So if it's telling you that they're similar, then we know that sides FO and HO are going to correspond. Sides OD and OG are going to correspond, and then sides FD and HG are going to correspond. So I already have them drawn separately here, and I've labeled the sides. We don't know what this long side is, FD and HG are, but we don't need to because we have enough information to go ahead and solve. So drawing them separately, because these are straight lines, we can go ahead and just give the value of them. You can solve for it using the distance formula, but with straight lines, I always just find it easier just to count how many spaces this one they go out. So FO goes out 4 spaces and HO goes out 6 spaces. So drawn as triangles, the side of the green triangle is 4, the side of the teal triangle is 6. And then going down, the green one is the one we're trying to find. DO is what we're trying to find. So I labeled that X. And then OG is -10. Since it goes in the negative direction, that's why it's -10. I know normally for sides of triangles, we can never have a negative value, but since we're dealing with a coordinate plane here, we're going to keep that as a negative. So then since we're solving for a side of the small triangle, the green one, I'm going to put that on top. So I'm going to compare X over -10 because those two sides are similar to each other according to the statement up here. And I'm going to say equals, since I started with the small triangle, the green one, I'm going to start with a small, a side on the small green triangle again, 4/6. And again, I highlighted these in yellow because they are similar according to the similarity statement. So now you have your proportions set up and you can just cross multiply to solve. So we're going to cross multiply both of these. 6x equals -40. And then when we divide by 6, x equals -40/6. So this can simplify a little bit to be x equals -20/3. If you divide these both by 2, that's how we get this. And so that's how they got this answer of -20/3. The other thing was they said, what's the scale factor? Well, if it tells you that two triangles are similar, you can find the scale factor by dividing any two similar sides by each other. So let's just look at OF and OH to find the scale factor. So I'm going to shorten this SF, which is scale factor, equals 4 divided by 6. Well, that reduces to 2/3. And so that would be your scale factor for this one. And you can take this scale factor and multiply it by any side to get another side in a triangle. So say, for example, you use the scale factor 2/3 and you multiplied it by -10, you could find what x is. And I'll just show you that. -10 times 2/3. So we got -20/3. -10 times 2 is -20. 1 times 3 is 3. So -20/3. So you see how these two answers match each other. All right, so that's it for number 4. I'm going to go ahead and go to number 5 here. So this problem is really similar to the one we just did. They give you a similarity statement again, and so that way we know Kj goes together with Wj, Kl goes with Wx, and then Jl goes with Jx. So again, I've already highlighted in yellow and green here so you can see the different triangles, and I've labeled them. JL goes in the negative direction, -8. That's where I got that from. We're looking for the value of x, so it would be how far Jx goes out. That's why I gave this a value of x right here. Jk goes up 6, so I gave 6 right here. And then Jw goes up 16, so I gave that a length of 16. So again, you just want to set up your proportions appropriately. Since we're looking for a value of the big triangle, I'm actually going to start with that one on top first. So I'm going to go x over -8. So that's comparing side Jx with Jl equals, and since I started with the big triangle, start with that again, 16 over 6. And that's because our similarity statement tells us that those sides correspond and are similar to each other. So then you're just going to finish solving. We got 6x equals negative, let's see, 128, and then we divide by 6. So x equals negative 128 over 6. That's going to reduce to negative 64 over 3, which is your answer here. You just have to write it as a coordinate. So that point x goes out negative 64 over 3, but the y is still 0. And then again, to get that scale factor, you can divide any two similar sides. So since they had already given us 16 and 6, you can divide those, and then the scale factor here, that's going to reduce to 8 over 3. So kind of like I said in the last problem, you could have found the scale factor first by dividing 16 over 6 to get 8 over 3, and then use that to multiply by a value to get your answer. So it's just a matter of how you want to do it. Sometimes I think it's easier to set up the proportions, but sometimes if it's a really straightforward scale factor like 2 or 3, it's easier to just multiply that by a value to get your answer quickly. All right, so just let me know if you have any other questions, and have a great day.